Hello and welcome to my video lesson 3.5 on inverse functions. So inverse functions can be thought of in two different ways, a reflection in the line y equals x, or a swap of all of the x and y values when it comes to the original function versus the inverse function. We can write that in two different ways, either like this, showing that little negative to the exponent -1 thing. But it's not really actually an exponent. That's something to be aware of, because if it's written as an exponent, if it's like this, right, then that would be the reciprocal function here. And this is not a reciprocal function, which you learned about in 20-1, but it is actually just where the x and y values switch places. So it's slightly different. Another way to write it is just here, where we literally just swapped the x and y values. So it's f of y equals x instead of f of x equals y. So when changing points, it's very simple. Simply swap the values. So the x switches to a y, the y switches to an x, and you can see that here as well. Just simply swap the values. Okay, and the same thing holds true with domain and range. If you just swap the x and y, y and x, then it works just fine. We'll take a look at some caveats to that in a little bit in some of the examples. So what you might ask is something a function? Well, to test if something is a function, first we can use the vertical line test. That is something that hopefully you guys have remembered from previous years. Basically, a function is anything as long as it passes the vertical line test. So any one of these vertical lines that I'm putting through, none of them are going through the graph twice. However, if we did this kind of differently, so if you can kind of imagine this is an original function, and this could be a inverse function. Here, now if we drew a vertical line, it hits the line in two places. So if it crosses more than once, it is not a function. We can actually tell this ahead of time. If we do the horizontal line test, notice that here I'll just do this. This was the inverse function, but the original function would have been like this, y equals x squared. And so this original function, you can tell if the inverse is not going to pass the vertical line test by doing a horizontal line test. So it works the same way. You can notice that when it flips, right, then it flips to being vertical. All right, let's take a look here. So this is the first example for today. Reflect the function below in the line y equals x. Just showing that we could use this reflection line, and I've drawn it as a dotted line here. But let's first of all start writing down some of our points. So our first point is -6, 0. Our next point is -4, 3. Our next point is 0, 3. Where else do we have one? And 6, -3. So we now have a bunch of points. There are a few ways to do this, but I recommend, especially when it's a weird function like this, I recommend putting it in this data table type of form, and then just simply swapping the values. I just swapped the x and y. I'm going to do that here as well, and here, and here. Okay, so now that we've done that, what does our new graph look like? 6, 0, -6, 3, -4, 3, 0, -3, 6, So like this. Okay, so hopefully that kind of shows it a little bit using those same few points. So we reflected in that line. That's the same thing as asking for the inverse. Find the domain and range of both graphs. So our original domain and range is going to look like this. So our domain is from -6 to +6. Our range is from -3 to +3. And so when we change it to the inverse function, it's just simply that we're swapping the values. So notice that we just basically swapped the order of these two, the range, the domain and the range. All right, I hope that helps a little bit. Let's take a look at another example. So here we have, just scroll down just a little bit. Fantastic. Here we have this original graph, and it's drawn for us already, and we're expected to find the changed graph, the inverse graph. So, well, what can we do here to find that inverse graph? We can find an invariant point, might be helpful. So if you just kind of imagine that dotted line for me, right? Anything on that dotted line, if it's being reflected, it actually doesn't move. So that point that I just marked in red is going to be on both graphs at the same time. We call that, and maybe I'll do that in purple actually, invariant point. Okay, everything else can move though. So let's just see here. This goes down 1 from that line, so this could go over 1. And so basically, if you look at the slope here, it's going up 1 or up 2 to the right by 1. So instead of going up 2 to the right by 1, we're going to go left by 2, up by 1. So it's going to look like this. I'm just going to put the dots down so we can kind of see it. There you go. It'll look something like that. And so hopefully you can see that that is a reflection or an inverse of the original function. All right. So the question here now is, well, is that inverse graph a function? Well, if we try the vertical line test and we put that through any point, yes, indeed, it is a function. Okay, so we don't have to worry about this part. Okay, if you wanted to check this one, well, is it a function here? Well, actually, no, because it hits in 2 places. It is not a function. Okay, let's take a look at our last one, the last example here. All right, sketch the graph f to the -1 of x if we have this absolute value function. Now, keep in mind our kind of normal rules for transformation. This means we're going to the left by 2. And then otherwise, it's the same as our parent function, which is going to look like this. Okay, so it's going to look something like this. Boy, I lost track there for a second. Okay, there you go. It's going to look something like that. But just keep an eye on that, especially that original point. Okay? Keep an eye on that. So that original point, one way to keep an eye on it is actually just to label it, which is the 0, -2 point. And it might even be helpful if we labeled 2 more of these points. Sorry, I did that wrong. It's -2, 0, and 0, no, negative 4, 2, and 0, 2. Okay, so those are our original points. I guess I could have done that in blue, but that's all right. So our new points are going to be 2, negative 4, 0, negative 2, 2, 0. So let's go ahead and start this. And then once you have a couple points down, you can see it's a straight line, so it should be relatively easy. The first one that we want to look at especially, most important point to move, is that vertex. So 0, negative 2, so that's going to end up being down here. And then we're going to have 2, negative 4. No, hold on. Say that right? Yeah. Oh yeah, 2, negative 4. There you go. I'm like, where am I looking? And then 2, 0. Okay, so hopefully you can tell that the graph should look something like this. Okay, with especially those 3 points that I chose, but the most important being that vertex point. And hopefully it's also kind of clear that this is also being reflected over the y equals x line. Every point is the same distance away, right? So that might help make it very clear. Okay, is the inverse graph above a function? Well, if we draw a line like this, you'll notice it hits in 2 places. So no, it is not a function. It does not pass the vertical line test. If not, how can we restrict the domain of the f of x, that's the original, okay, to make it a function, to make the new one a function? Well, we can restrict it in 2 ways. Basically, that negative 2 value, if we make our x values greater than negative 2, okay, that would be the same thing as writing our y values are greater than negative 2. Or we could write our x values are less than negative 2, which is the same thing as writing our y values are less than negative 2. So depending on how you want to go about, cutting this up, but basically if you drew a line here and said everything bigger than that, or everything smaller than that, but not both, okay, you have to pick one. And same thing here. You should say this direction, or you should say this direction, but not both. So there are 2 different restrictions. Pick one. Okay, it depends on how the question is labeled. If it says, how can we restrict? We could do this, or this is one way you could write it. If you say and, it's wrong. Okay, and the same restrictions when applied to the inverse graph would be would obviously just change the x and y values. So just the same as how we did the domain and range over here, just flop them, same thing. All right. I hope this video helps you guys better understand inverse functions, and especially how to reflect a y equals x line. Good luck.